Okay, guys, as promised, this is maybe the last video or second to last video, depending on how long these questions are taking. But we're going to approach these remaining questions here. And I'm going to kind of blast through them. Okay, so I have our list of questions here, and then we'll do the graphs one by one, like we do. Yeah, this is our working area here. Nice big old graph. Here's x, here's y. Okay, starting with the square root of negative x. Okay, first of all, let's remember our good old friend square root function. Start with the original. What is the original square root function? Starts right at the origin, right? And I can take a square root of 1 and get 1. Or I can take a square root of 4, 1, 2, 3, 4. Square root of 4 is 2, and get 2. So I got those points. This is my original y equals square root function, right? Now, this time I have a negative inside. Inside means it should be a reflection, but reflection horizontally because it is in the inside of the function, right? The square root being the function. Okay, so that means still starting the same spot. There's no translations. Instead of going 1 to the right, I'm going to go 1 to the left. And then up same amount. Instead of going 4 to the right, I'm going to go 4 to the left and then up the same amount. And so I got this function here, this graph here. Yeah. Here's the point 0, 0. Here's the point -1, +1. And this is -4, +2. Okay, now it asks us to also give a domain and range, right? So domain, normally originally it was from 0 onwards, but now it's reversed. It's going to be -infinity up until 0. And what's the range? Range starts from the lowest value is 0, and then it goes up as high as you want, so to infinity. Hey, there you go. That's number 10. Okay, now to number 11. Yeah, I think we can crank this out one video. Yeah, I don't know. Maybe I should split it up anyway though, because it's better to have little shorter videos if we can. So you don't get too exhausted. All right, so number 11 now. This is number 10 done. Number 11, same starting function, right? I shouldn't have erased it. Same starting function at this point and this point. Okay, now this time the negative is outside. So outside means I'm gonna flip over the x-axis this time. So it should be this one down 1, right 1 down 1, right 4 down 2. So now it's this. Let's pretend I hit that point. So there you go. This is negative square root x. Okay, and what about domain and range? Domain, you can start from 0 and go onwards forever. And the range, you can start from 0 and go downwards forever. So that should be -infinity. Oops, I wrote that all wrong. Sorry. -infinity is smaller, right? It's -infinity up until 0, and you can't hit 0. 0 is possible. There you go. Number 11, done. Okay. Number 12. Okay, number 12. What is this? What's this guy doing here? 3x minus 5. That's just a line, right? Easy. You don't even really need translations. This is intercept of 5, slope of 3, 1, 2, 3, boom, boom. Connect the dots. There's your graph, right? We all know that. Okay, but sorry guys, I'm gonna belabor this a little bit. This is really just the line y equal to x, but then translated, right? So this is y equal to x is my original function here, like this, right? But then what's happening to y equals to x? Okay, you have. Let me keep that original because that's y equal to x. What's happening to that thing? Well, here it's being multiplied by a number, and then it's being moved down. So multiplied by a number means from my starting position, normally I go out, up 1, out 1, up 1. This time I'm going to go out 1, up 3, 1, 2, 3. Like this, right? So this is my new line, like this. Okay, and then now take that line, and it's gonna move down by 5. So 1, 2, 3, 4, 5, right there. That's the new line. But hey, that's what we graphed earlier, right? With the slope-intercept form. So you already know how to graph that. But just showing you that you can think of this as actually being a line that was just translated. Okay, that was number 12. So let's just cross it out in black. Okay, number 13. Okay, looks like the underlying function is x cubed here, right? What's x cubed? Remember x cubed? Okay, starts from the 0, right? 0, 0, 0 is still a point. And then another one of our friends. Out 1, up 1, out left, down 1. Because negative 1 cubed is negative 1. If you go out to 2, 2 cubed is 8. 2, 4, 8, right? So 1, 2, 3. This thing does not look accurate. Let me try it a little better. 1, 2, 3. No, stop looking. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. So here's 2. 2, 8, right? And then negative 2. Down 8, 1, 2, 3, 4, 5, 6, 7, 8. So negative 2, 8 would be down here. And right there. So the original graph looks something like this. Remember this from last class? Okay, now what's happening here? Well, my starting position is 1, positive 1, comma 5. So new starting position at 1, comma 1, 2, 3, 4, 5. Okay, what's happening now with that? It's there's no stretching, but there is a negative outside. Negative is outside of that thing, which means it's gonna flip. So the negative happens after the cube already happened, right? So the function already happened, and then there's a negative. So that means it's flipping over the x-axis. It's a vertical flip. So normally where I would go 1 to the right and 1 up, this time I'm gonna go 1 to the right and 1 down, and 2 and 8 down. So 1, 2, 3, 4, 5, 6, 7, 8. It's gonna be over here. That's the right hand side of the graph. And the left side, instead of going to left and down, I'm going to left and up. So right here. And then left 2 and up by 8. Right? So 1, 2, 3, 4, 5, 6, 7, 8 over here. Something like that. I think this connects like that. So the blue graph is the end result. This thing right here. And now we give our domains in range. So domain first. Looks like I can go to the left forever, right? As long as I go far enough, this thing is going to continue going left. It's going to continue going right, so I get everything. Negative infinity to positive infinity. What about the range? Well, I can go as low as I want or as high as I want. So also negative infinity to positive infinity. That's number 13. Done. Yeah. Okay, this is taking, taking a decent amount of time for these. So it actually is going to make total sense that we split this video into 2 parts. So okay, number 14. How much should we do? Let's do a little more than half. So 1, 2, 3, 4, 5. Let's do 2 more, and then we'll cut it off. Back to red. Okay, we got absolute value function here. Remember the original absolute value function looks something like this, right? You start at 0, 0. You go 1 up, 1 to the right, 2 to the right, 2 up. It looks like a V like this, right? This is the original absolute value function. Looks like that. Right? Okay, what's happening here? Okay, starting position is going to be negative 3, comma negative 4. So remember, it's always opposite sign, yeah? Negative 3, negative 4. Okay, so 1, 2, 3. These guys are in the way, sorry. Negative 3 is right here, and then negative 4. 1, 2, 3, 4, negative 4. So my starting spot is right here now. Yeah. Now look, there's any stretching or anything? Yep, there's a stretch by 2. So that means normally where I go 1 out and 1 up, I'm going to go 1 out and 2 up to here. and here. 1 out, 2 up. Yeah, 1, 2. So connect those dots. This is my 2. See how it's like a little sharper, a little V? That's the technical language. And then I'm just joking, it's not technical. So it's sharper than the original, right? It's narrower and still opening up the same direction because there's no reflection, starting from the point -3, comma, -4. This is the point -2, comma, -2. And -4, comma, -2. Like that. Okay, that's 14. All right. Let's clear this graph out. Okay, now for number 15, another absolute value function. So we already know starting graph looks something like that, right? This time, what's happening? Okay, the center point, there's nothing in the middle, so that part stays still. 6 down. So it should be 1, 2, 3, 4, 5, 6 down. It should be starting position right here. And then this time multiplied by 3. So stretch of 3. Normally where I go out 1, I go up 1. Stretch of 3 means, stretch of 3 means I go out 1 and up 3 instead. So 1, 1, 2, 3 here. And same thing on the left, out 1, 1, 2, 3 here. Okay. So those are going to be my new points. Purple here. Something like that. Something like that. You know, my tick marks aren't exactly accurate because I'm just doing it by hand, but that's the idea. So if you want it to be perfectly accurate, use a graphing paper. That's 15 done. Okay, guys, I said I was going to stop here. So let's stop here. And in the last video, I'll tackle the last 5 problems with you.